Alpha 52, Statistical Methods, Chapter 4, Discrete Probability Distribution. So in this lesson, we will be covering probability. How do we come up with those numbers? Building on the last section, which was Chapter 3. So we get into the types of data that we're collecting and how we calculate our probability based on that. So, random variables. This represents a numerical value associated with each outcome of the probability distribution, denoted by X, and these are some examples. So the number of sale calls a salesperson makes in one day. So we're going by each employee and collecting that information. Hours spent on sales calls in one day. So again, we go by each person and collect that information. So there are two types of random variables. The first is discrete. Discrete random variable. With this is that this has a finite or countable number of possible outcomes that could be listed. So finite just means that there's a maximum, and normally it's natural. So like for a set of dice, you only have 6 sides. Not a set of dice, but just one die. You only have 6 sides. That's natural. You can't change it. The number of players on a team, that's maximum. You can't change it. Normally because of juries and whatnot, but normally they have a set number. It's natural. Yes, you can count this, or it's naturally there. It's just it has a maximum, it has a cap to it. And a continuous random variable. Next. Has an uncountable number of possible outcomes, represented by an interval on a number line, and may sometimes be measured with an instrument. So continuous just means that we are looking at data that we can have in betweens. So with discrete, normally it's 1, 2, 3, 4, 5, the whole numbers. Continuous, you can go in between. So weight, you can go in between. There's a weight in between 155 and 156, and you can measure weight with a scale. But when I'm counting desks in a room, I don't have 1.5 desks. I either have a whole desk or no desk at all. So that's the difference between the two. We'll look at 2 examples to make sure you're good. Determine whether each random variable X is discrete or continuous. Explain your reasoning. Let X represent the number of Fortune 500 companies that lost money in the previous year. Fortune 500 companies. So Fortune 500 companies, remember, can we measure a company, or are we going to count companies? Can we measure companies or count companies? Okay, right. We can count companies. Count the number of companies that lost money in the previous year. Alright, and the next, let X represent the volume of gasoline in a 21-gallon tank. Volume of gasoline in a 21-gallon tank. So how much is in that tank? So are we going to count the number of gallons or measure the number of gallons in that tank? This is finite, but we're not looking at the actual tank itself. We're looking at what's going in it. So we're looking at the volume, and volume is a measurement. This is something to answer. I didn't even do it. Continuous. So continuous, because we measure volume. Let me turn my email off so it won't be disturbed again. There we go. Alright, Alright, so for 4.1, we're going to look at, or chapter 4, we're going to look at discrete variables, and then chapter 5, we'll look at continuous. So discrete probability distribution lists each possible value the random variable can assume together with its probability. A discrete probability distribution must satisfy these conditions. So the probability of each value must be between 0 and 1. So we talked about probability, it has to be between 0 and 1, so we know that already. So we can also check to make sure that we've accounted for every probability by adding all the probabilities. Check to make sure each of them are between 0 and 1, and then when you add them together, it will give you 1. So now, remember, we're going to be rounding some of these numbers in between, so that means when you add, you may get like 1.001 or 1.003 or something like that, because we're rounding in the middle of our problem. So we want it to be exactly 1, but if it's not exactly 1, it's fine. Okay, so when we have a final answer, we know we're rounding those numbers, and that makes a difference. So if it's 0.9999, it's fine. It's still 1. All right. So the discrete probability distribution we're talking about. So distribution, remember, this means table. So we're going to pretty much put this in a table. Put it in an organized way so we can see it and check it to make sure all of them are between 0 and 1, which means they're decimals. So this means that they're a decimal. And that when we add them all together, they equal 1. So how do we construct a discrete probability distribution? Construct this means we're going to put it together. So we're going to make a frequency distribution for the possible outcomes. Find the sum of the frequencies. Find the probability of each outcome by dividing its frequency by the sum of frequencies. And check that all the probabilities are between 0 and 1, and that the sum of all the probabilities is 1. So this last one is just checking to make sure we check what we just learned. It sounds so crazy, but discrete probability distribution is relative frequency. So this is that time where we are seeing the word relative frequency again. Relative frequency. So discrete probability distribution means we want to find the relative frequency. So we're looking for every single possible outcome, and then we're going to look at the frequencies of those outcomes and calculate the relative frequency. I know. We've done it before. It's just giving it another name. So we're going to divide the frequency by total frequency. Divide the frequency by total frequency. Alright, let's go to an example. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. So that's our total frequency or sample size. Remember, sample size is going to be it's going to have different names throughout this class of sample size. Each individual was given a whole number from 1 to 5, so those are our possibilities. Where 1 is extremely passive, 5 is extremely aggressive, and 3 indicates neither trait. The results are shown on this page. Construct a probability distribution for the random variable x. Doesn't that seem like it's real crazy? Probability distribution for the random variable x. That means you're going to find a relative frequency. And put it in a nice graph. And we're going to graph it using a histogram. So whenever you have distributions, we use histograms. So that means those bars are going to touch. Alright, so we want to make a table and then make sure the bars are touching. So here's our frequency distribution. So write that down somewhere you can. This is our frequency distribution. This is our x. This is the data that was collected. This is how many were collected. Okay. So they gave us the frequency. They didn't give us a total frequency. If they don't give you total frequency, add it yourself. Oh, actually, they did for this one, didn't they? They told us it was 150. Lucky for us. They went ahead and told us what, how many we had in our sample size. So we either add all those together, or if they tell you what it is, you already have it. So I like to make my graph in a different one, my distribution in a different way. If you wanted to, you could just add your probability here on the side, but I like to keep it separate so that I can see my data. Okay, I'm doing it this way because the book does it this way sometimes. Just want to let you know it doesn't matter whether you're going vertical or horizontal. You still have the same graph. All right, let's look at all of our possible x's. So we always list our possible x's. So what we're working with, and then we calculate probability. So for this first one, we're looking at the frequency divided by total frequency. Frequency divided by total frequency. I like to do 3 or 4 digits out for these. I do 4 if I have a probability that is like really, really small. But I'm going to do 3 for this section. Okay. So the next 33 over 150. These are coming out to be really nice, clean numbers. So don't need 3. The next, what you got? The next. So for probabilities like this, in case you went ahead of me, probabilities like this, I like to go ahead and put a 0 there so I can have it in relation to the others. I don't want to mix this up with 0.02. This is 20 cents as opposed to 2 cents. So I'll put a 0 on here so it can look like my other numbers. You don't have to, but I put a 0 there so it can look like my other numbers. Alright, and that means you should have that last one. So this is a discrete probability distribution of a random variable x. That's it. I know. They make it so hard. So again, this is a discrete probability distribution of a random variable x. We have a random variable x and its frequency, so the frequency distribution, and we converted the frequency distribution into a discrete probability distribution of a random variable x. Random variable x just means what was collected. What are your x's? And then what's the probability of getting each? Alright, you don't have to do this every time, but if you don't feel good about it, like something's telling you, man, I think I might have something wrong, this is where you're going to use that checking system. You're going to check to make sure all of your probabilities are between 0 and 1 inclusive. Meaning you can have a 0 probability or a 1 probability. And all of these are decimals, so we're good. Now we're going to sum all of our probabilities. So there's that little, I had someone in the class the other day refer to this as the ugly U. Yeah, ugly U. Some people use that ugly U. Okay, so this is the summation symbol. We're going to add all of our probabilities. And what are we looking for? What's that number we wanted to add to? We want all of these to equal 1. So take a minute, pause, add them all together. Yes, they're all equal 1. So I know I did my probability, my discrete probability distribution correctly. Now let's look at graphing this. Remember, this is a histogram. I normally use my faithful fives on the side because it normally does the trick. So here we want to put our x's, the data that we collected. Here we're going to put our probabilities. And I'm going to use my faithful fives. 5, 10, 15, 20. Let me see how far that go up. So 25, 30. So I know 0 is probably my lowest. Faithful fives all the way up to my highest probability. Now I'm going to draw my score. So for my x equals 1, I'm going up to 0.16. X equals 2, 0.22. Remember, this is a histogram, so the bars have to touch. 3 is 0.28. 4 is 0.20. And then 5 is 0.14. What shape is this distribution? What shape is this distribution? This is going to be symmetric. Good. So always look to see if you can identify the shape of distribution. They're not always going to be a shape, but if you can't see a shape, they may just ask you, do you see a shape? Okay. So if there's no shape, don't make it a shape. If there's a shape, tell them what the shape is. Okay, so real data sets, normally you don't have a shape, not unless you're doing something that is even. Yeah. Okay, so I have a calculator function down here to tell you how you can use your calculator to calculate all of your discrete probabilities at one time. So we did everything manually, but let me show you how you can click to the calculator. Alright, so stat edit to put our information in. So remember, L1 is always our x's. L2, the frequencies in there. L3 is where we're going to tell the calculator to calculate all of our frequencies at the same time. So what we're going to do is we're going to tell the calculator to take the numbers in L2 and divide it by our total frequency. And then the calculator is going to pop them all out at one time. Alright, so this might take a couple of times for you to practice. So if you need to review this a couple of times, it's okay. So let me go back up here. So once it's stacked, edit. I have something in my L1, so I'm going to go up and clear this. Don't delete. Just clear. So you never want to delete anything. You always want to clear. I'm going to put my possible x's in L1. Let me get it clear out. There we go. Then we're going to hit that right arrow, go over to L2, and put my frequencies in. Here's the tricky part. Here's the part that this is one of the reasons why I don't do this very often, because I don't like to mess this up. So I'm going over to L3. I'm not going to write in here. This is where I want the calculator to calculate all my numbers. Okay. I want to go up to L3 when it's dark. up to L3 when it's dark. Hit enter just once so that I can enter something in L3. So I want to do L2 divided by 150. L2 divided by 150. So L2, so second, number 2, divided by my total frequency. If you go back and watch it again, pause it, move that little thing. Okay, so we're back. L2 divided by 150. So this is saying I want you to calculate all of my frequencies and divide them by my total frequency individually. Once you hit enter, all of our probabilities are going to pop up. I know cool, right? So 0.16, 0.22. So it'll pretty much do all the work all at once, so you don't have to. So you can use this here, and then you can use it in 4.2 if you like. Yeah, 4.2 if you like. So if you're comfortable with just doing them by hand, just do them by hand. I normally do them by hand myself because, you know, it's just the L2, L3 thing. If you don't do it right, you'll end up trying to clear this and you actually delete it and delete your whole list. If that happens, contact me and I can tell you how to reset your calculator to make your L3 come back up. Okay, because there's no way to just add it in, unfortunately. Alright, so you can use that if you like. If you don't want to use it, you don't have to use it. Alright? So now I want to talk about how are they going to ask you questions and how are you going to get those answers. So find a probability of choosing someone who has a score of less than 2. So let's look at our possibilities and all the scores that are less than 2. Oh, I can actually use this score less than 2. So this is not less than 2, this is equal to 2. So less than 2 means 1. So let me work this out algebraically, so you can see algebraically, and then we're going to break it down. So all x's less than 2. All x's less than 2 equals probability of 1, or x equals 1. Alright, so all the x is less than 2 means we're only want probability of 1, so P1 for x equals 1. So P1 is equal to 0.16. So less than 2 does not include 2. Let's look at the next one and it'll make a little bit more sense. Find a probability of choosing someone who has a score of at least 3. At least 3. So I'm going back up to my probabilities. At least 3. So if you have at least $3 in your pocket. So if you can't really grasp your mind around, you know, what those terms mean in terms of dollars, that's what I always do. So if I had at least $3 in my pocket, I have $3, $4, $5. I can have $6, but that's not one of my possibilities. Okay, so $3, $4, $5. So at least 3 does include 3. So algebraically, or inequality-wise, I'll say this. At least $3. At least $3 equals so this means x equals 3, 4, 5. Hopefully that makes sense. So all the x's greater than or equal to 3, that equal sign means it's included, I didn't include it there because two wasn't less than 2. But at least 3 is 3, 4, 5 $3. 3, 4, 5. So we're looking to add P3, P4, P5. P3, P4, P5. So I'm going to take 0.28, 0.20, 0.14 and add those together because that's P3, P4, P5. P3, P4, P5. So look at the wording and see what X is included. Okay. So next, we have the mean variance and standard deviation. So yes, we're working with probabilities. So now we want to find the mean of our data set based on our probabilities. Okay, I have a break, so hopefully this is fluid. So mean variance and standard deviation of a probability. So we can actually calculate the mean of our data set based on probability. So this is probability of probabilities of mapping and standard deviation. Alright, so here are the formulas to do so, but I'm going to give you the option of working these out by hand because the mean I'll do by hand, but the variance and deviation, you can look at the formulas and calculate them by hand yourself if you'd like. And don't forget, these are actually on your formula sheet. So we're in chapter 4. So mean of discrete random variable, just let you know that's the type of data that we're working with, discrete. And this, that finite, you count these, and those are the formulas. Okay. So the calculator, how to calculate those in the calculator. You're going to list the data and frequency, and that's stat, edit, enter part. L1 is still going to be your X's. You always put your X's in L1. L2 is going to be the probability of X, your P of X. That goes in L2. So you can either calculate it by hand or to the calculator calculate it itself. And if you do the calculator calculating your probabilities, you'll probably want to put your frequencies in L2 and your probabilities calculated in L3. But I just suggest you put them in the L2 so that the calculator will do what it's supposed to do. Alright, so find the mean and standard deviation and variance. Stat count, 1 bar stat. Don't forget, if you have an older calculator, your screen needs to say 1 bar stat, L1, comma, L2. Older calculator just means you have that gold screen around it, that gold edge around it. Yeah. But for me, standard deviation. So notice our symbols are population. So we only deal with population when we are working in chapter 4. Only population information. Only population. And then for variance, we want to square that standard deviation. And if you remember how to square your standard deviation in the bars stat part, you can do that, but we're just going to square our standard deviation to variance. Alright, so let's find the mean variance and standard deviation for the given data set that we do have. So let me back out. So we can do all this together. So stat, edit, I'm going to put my probabilities in my L2. check. I'm leaning to the side and doing this at the same time to make sure the glare is okay. That's why I'm a little off. So my probability in L2 and L1. So if you leave your probabilities in L3 because you let the calculator do your probabilities, you will just tell the calculator that your frequency distance in L3 as opposed to L2. So the calculator automatically does L1, L2. So if you put your frequencies in L3, no biggie, you'll just need to tell the calculator on this next screen. So second mode to get out of that, let's go back to stat. I'm going to explain what I was stating. What's that? So this is in L1. My probabilities are now in L2. So if you decided to let the calculator calculate your probabilities and going to keep there, you'll just change that to L3. Now make sure you change this when you go back to another problem and then come back in. Just make sure you change this to the correct list. You want to do that. Okay? So let's look at our mean. Remember, the calculator always does that symbol for this symbol. And you round to whatever. So you round to normal, it's 10 there's 10. I'll just put both the numbers because it's my same number. Standard deviation. Notice that it doesn't have a sample because the calculator knows that if you put it in correctly with the probabilities, it knows that you're only dealing with the population. Okay, but for some odd reason, you do the L1, L2, L3 thing, it may give you this, and you're going to have to remember that this is our standard deviation. So 1.27 is our standard deviation. To get variance, we want to take at least 3 or 4 digits out and square it. So 1.2713. I'm going to bring that back up. 1.2713. I did not round. I don't want to round in the middle of my problem. I don't want to round in my problem because it's going to cause problems down the road. So I rounded this to get my standard deviation. I don't want to use this to get my variance. I want to use at least 3 or 4 digits to make it the best variance answer I can get. It's not going to be perfect because I have to cut these numbers off. So I want the best number I can get. So 1.2713 and square it. There's a square button right there. 7, so this is our variance. 1.62. This is the point where I can round. I don't want to round here. I want to round that last number. So 1.62. We're going to do a problem and calculate the mean by hand. So we know how to do it in the calculator. I'm going to show you how to do the mean by hand on this next part. Expected value. So expected value is the mean of a discrete random variable is equal to the mean of a random variable. So expected value, whenever we see it, this is in your formula sheet as well. Expected value just means we want to find the mean. So expected value is what do you think you'll earn, or what do you think you'll lose when you're working with discrete times and pretty much gambling or raffling. I know it's bad. So if you know the number of raffle tickets printed off, you can actually calculate what you expect to win or lose based on your winnings and your loss. Okay, so let's look at that. Let's expect value. What do you think you'll win or lose? So we're going to calculate it using the means. I just put those steps there. But let's set up a problem. So all we're doing is finding the mean. At a raffle, 1,500 tickets are sold at $2 each for 4 prices of $500, $350, $150, and $75. So that's 4 prices. You buy 1 ticket, find the expected value, and interpret the mean. unexpected value, interpret the meaning. So first we have to look at all of our prizes going from the highest prize to lowest prize. And that's going to be our X. Alright? Well, no, highest prize, lowest prize. That's going to be where we're going to start. Our X is going to be our net win. Our net win. So remember, you're paying for a ticket. So if you're paying for a ticket, you didn't actually win all that money because you put money in. So for our first prize, it was $500 winning, but we spent $2. So we actually only won $498. Okay? So $500 we won, but we put $2 in, so we actually won $498. And we're going to do that for all of our winnings. So $250, but we put in 2 for second prize. That was with $248. $150, but we put in $2. That leaves us with $48. The last prize, $75, but we put in $2. So those are all the winners, but we have to count for all those losing tickets. So out of the 1,500, we have 4 winners, everything else loses. So we didn't win anything. We paid $2, so we are at -2. So we won, put in $2, one put in $2, one put in $2, one put in $2. We didn't win, but we still put in $2. So everything has to be accounted for. Alright, so now we're really looking at the probability of one ticket for all of these. So it's not like it's you pick one ticket, then another ticket, then another ticket. You only buy one. So we're trying to figure out what's the probability of you picking that one. So what's the probability of you getting first prize? 1 out of 1,500, right? What's the probability that you pick that second prize winner? It's only one of them. It's only one of those third prizes. It's only one of the fourth prize. So how many losing tickets do we have if we have 4 prizes? Think about it. 1,500 tickets altogether. 4 winning tickets. So that's 1,496 losing tickets. So you have 4 winning tickets, and then all your losing tickets. Alright, so we can see all of these are fractions. So I don't have to check to make sure it's 2, 0, and 1. Because I'm going to let a calculator do some of this work too. But I do want to make sure that I have accounted for all of my tickets. So my winning ticket, first prize, second prize, third prize, fourth prize, and the losing tickets. First, second, third, fourth, and all losing tickets over the 1,500 tickets all together. We're good. They all equal 1. So you want to make sure, if you don't feel right, just check to make sure all tickets are accounted for. If you don't feel right, make sure they're all accounted for. Alright, now we're going to put it in the calculator and we're going to work it out by hand. So let's work it out by hand first. So let me go back to this. So work it out by hand. I do this one by hand because a lot of people like to do it by hand for some odd reason. I teach a calculator, but people revert back to this. So we're going to take each probability of x, or each wins, or each probability we have of x, and multiply it by the probability. So to get mean, we're going to do 498 times 1 over 1500 plus 248 times 1 over 1500 plus 148 times 1 over 1500 plus 73 times 1 over 1500 plus negative 2 times 1496 over 1500. And this is how it looks in the calculator. So let's put this in together. I pause just to make sure everybody was good. And make sure you put in negative, plus negative 2 or minus. Don't put plus minus. It's going to be plus negative or minus. You can't do plus minus. So the negative is all the way down the bottom on your calculator. So don't hit the minus sign, hit the negative sign. That's negative 4.35. That's already in money form. So that is going to be a negative $1.35. And we'll interpret that in a minute. Okay, so I took my x times my p of x according to our mean formula, sorry. Multiply all those and add them together to negative 1.35. Now put this in the calculator. L1, remember always our x. L2 is going to be our p of x. So we're going to put this in a list and we still get the same answer. So up top of this page, I'm not going to put my screen down because I want to show this all the time. Stat, edit, and then all my possible x's going L1. So 498, 248, 148. 73 and negative 2. And we don't put minus 2, put negative 2. Now for the probabilities, the calculator is going to calculate this for you. 1 over 1500. Remember, that's not 6. That's 6.75 e negative 4. So we're moving that to 0.0007. Okay? 1 over 1500, 1 over 1500, 1 over 1500, and then 1496 over 1500. So the calculator will actually calculate this for us this way. Okay, so second mode to get out. Going back to stat. And can only do one bar stack. So I like to keep my L1 and L2 probabilities the same because the calculator automatically picks it up. So if you change that to L3 the last time, make sure you change this back to L2. Or if you have that older calculator, one bar stack, L1 comma L2, same answer, negative 1.35. So it's up to you how you like to do these problems. Some of you will love to use that list. I'm not a list girl. But the list will get you all your answers all at once and it just makes life a little bit easier. I just don't like to use it. So no pressure to do anything my way. Okay? So how do we interpret this? So negative means we can expect to lose some money. That's what negative means. So you can expect to lose and if it was a positive, it would be gain, but of course it's a negative. We can expect to lose $1.35. So we're not going to put a negative. Lose means negative. Gain would mean positive. Lose $1.35 on average for every ticket you buy. So we'll go back over this problem one more time to make sure you're good. If you're good, you can stop here, but I'm going to back over one more time. So here for our x's, we always calculate the difference from our winnings and how much we actually purchased to get your x, because we want a net winning. Then we want to calculate how many winnings you have of each of those. So I have one first prize, one second prize, one third prize, one fourth prize. It could be that they're giving out 5 gift certificates, so that would change to a 5 if it's a 5. Okay. Make sure everything's accounted for. 1, 2, 3, 4 plus 1496 is 1500. And then either you're going to multiply your x times probability, add those together, or you can put it L1, L2 in your calculator. Alright, 4.2, binomial distributions. So with 4.2, this is going to take a little bit more time than most sections that we have. So buckle down, make sure you got some time to focus, because it's going to get a little crazy. But most of the time when people get through this section, they'll learn the way that they like to do this and they'll stick with it. So don't try to cross. If you want to learn all the ways to do this, you can like double check yourself or triple check yourself. You can do this, but don't panic. Just learn your one way and stick with what you want to do. Okay. So binomial distribution. A binomial experiment is a probability experiment that satisfies these conditions. The experiment has a fixed number of trials where each trial is independent of each of other trials. There are only 2 possible outcomes of interest for each trial. Each trial outcome is classified as success or as failure. So that means there's only 2 outcomes: success, failure, nothing else. Success, failure. So failure doesn't mean bad. Failure is just not what we're looking for. So failure does not mean bad, just not what we're looking for. And then I'll skip over the first part. Has a fixed number of trials. That means that the trials. Let me fix my microphone. The number of trials are fixed. Like, you can't take one away at any point. The number, it is what it is. If we had 10 people in the beginning, we have 10 people in the end. If we have 5, then we have 5. Okay? That's fixed number of trials. And then the probability of success is the same for each trial. So we can't change the passing rate. We can't change P. We can't change the passing rate of P. And the random variable X counts the number of successful trials. Okay, so again, probability of success is going to be P, and P cannot change. And we'll look at a problem where that makes more sense. Alright, so here are the notations. So wherever your formula sheet is in your card where you have all your symbols, here we go. So N is the number of trials. So here's that N again that we always see as sample size. This is sample size. So N will have different faces, well, different names, but it's the same concept. It's a sample size. The probability of success in a single trial is your P. This has to be a decimal. So the more we give it to you as a percentage, we're going to make it a decimal. Your passing rate, P. So P is your passing rate. P is your success rate. P is what you're looking for. If I have a bag of M&Ms and I'm looking for red M&Ms, red is my passing, yellow is failure. Yellow is still a good M&M, it's just a failure. Okay. The probability of failure in a single trial is Q. This has to be a decimal as well. And to get Q, Q is the opposite of P, or the complement of P. So if I have a 30% success, 60%, 70% failure. It's just the opposite of it. And this part right here. So X is the number of ways you can have success when you're running a trial. The number of ways you can have success. So the one everybody forgets about is there's a possibility of you having no success. A lot of times that's really, really rare and unusual, but there's a possibility of no success. So there's a possibility that if you get a pack of Starbursts that you have no pink. There is a possibility. Very rare, but there is a possibility you have no pink Starbursts. So 0, 1, 2, 3 successes all the way up to your end. So X is going to be all of your N trials, all of your sample size plus 0. So let's kind of break that down. We'll look at whether these are experiments or not, and then explain why. So surgical procedure has an 85% chance of success. A doctor performs a procedure on 8 patients. The random variable X represents the number of successful surgeries. So first we want to know what is our N. N is, how many patients do we have? 8. P. P is our number of success. Or percentage of success, sorry. 85%, which we change that to a decimal. So normally I just go straight to the decimal, but I just wanted to make that correlation. Q is the opposite of P. So this is 1 minus P. So this does not change. This doesn't say anything about our success rate changing in the middle. So we're good so far. Our trials will not change, so we're good so far. So we have a binomial experiment. So what are the ways that we can have success? Out of all 8 patients, what kind of ways can we have success? So there is a possibility that none of the surgeries are successful, and 1 surgery is successful out of 8, 2 out of 8, 3 out of 8, 4 out of 8, 5 out of 8, 6 out of 8, 7 out of 8, and then all 8 are successful. So none successful, all successful, everything in between. So none successful, all successful, everything in between. That's all of our possible x's. I normally like to, in the beginning, list all your possible x's until you can get used to having a 0 in the front and then all the way up until our n. So this is a binomial experiment. Okay. So the second one is not going to be a binomial experiment, and we're going to break this down of why this is not a binomial experiment. Alright, a jar contains 5 red marbles, 9 red marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. The random variable x represents the number of red marbles. Alright, first, let's identify N, P, Q, and then we'll talk about why this isn't a binomial experiment. So N, it doesn't tell us outright how many marbles we have, so we have to calculate that ourselves. So 5 plus 9 plus 6. That's 20. Okay. Then our P is going to be, what are we looking for specifically? The random variable x represents the number of red marbles. So how many red marbles do we have? We have 5. So 5 red marbles out of the 20. That gives us our percentage. So sometimes they won't give you your passing rate. You have to find it on your own. Sometimes they won't give you passing rate. You have to find it on your own. So you look at your total frequency or your sample size or your total number of trials. Identify what you're looking for specifically. Look for red marbles. And this is 0.25. Our Q is going to be 1 minus this. Not bad, it's just not what we're looking for. So here's the issue. When we look at the X, it says you randomly select 3 marbles from the jar. So, out of all of our possibilities, 0, 1, 2, 3, 4, 5, I'm not going to write all those all the way to 20. They want to pick 3 marbles from the jar. Here's the issue. They state that they're not going to put the marble back. So if we take marble number 1, we're good. It's when we take marble number 2 where we have the issue. When I take marble number 2, I no longer have 20 marbles because I didn't put that first one back. I didn't put that first red marble back. So, if I didn't put that first red marble back, my N now becomes 19, and my P changes. Why? I didn't put the red marble back. So now I don't have 5 marbles to choose from. I have 4 red marbles to choose from. I don't have 20 anymore. I have 19. So that means P is going to change. That means Q is going to change. It's going to change everything. It's going to be too much happening. That's why this is not a binomial experiment. For me not putting it back, it's going to change my N, and it's going to change my P every time I try to calculate my probability. So anytime something is not replaced, it is not a binomial experiment. Do not work it out, because your numbers are not going to stay consistent. Okay? Alright, so let's look at how we calculate these binomial probabilities. The first way is manual. The second way is through calculator. And we're going to practice these two with the one on the bottom. And then the third way is going to be with our list. So we're going to go through all 3 ways after we get through the first 2. Alright, so manually, If you like to work these problems out in a way that's logical for you, here's the way that you work it out manually. Your P of X will be your success. Remember, that's a 0, 1, 2, 3, all the way to your N. So if we have P of X manually, we're going to find out ways that you can get success from there. So it's going to be NCX. It's a combination of N, your sample size, what are you picking, the probability of you picking that success, and then how many failures do you have, so what's left over. We're going to work it out. It's going to make sense. The next part, I don't put this in with letters because it depends on your calculator. So to find only one probability, like only one of these at a time, you're going to use Binomial PDF. So at this time, bring up your calculator, press second and bars. And we're going to find the Binomial PDF in your calculator. Second. And then bars is right here. And find Binomial PDF. You're going to have to go down. So I have PDF for A for me. PDF A for me. And go ahead and write down your CDF right below it. For me, it's B. So it could be yours is 0 and A. Mine is A and B. So if you need to pause and find it, pause. So if I'm on PDF and if I'm on CDF, I'm going to talk about each of those. Alright, pause. So to find only one probability, meaning one of these at a time, you're going to use Binomial PDF. Your trials will be your total number of outcomes for your sample size. P would be your success in decimal form, and then X is your number of successes. If you have that older calculator, it's not going to ask you for anything. You're going to have to put in this format. N, comma, P, comma, X. N, comma, P, comma, X if you have that older calculator. The gold screen. That's my favorite calculator. This is what I started off with, stats in, so I'm pretty proficient at that old one. The new one's pretty, okay, but I'm comfortable with the old calculator. Okay? To find more than one probability. So if we're doing the like less than 3 would be like 2, 1, 0, or at least 5, 5, 6, 7, 8, 9, 10, 11, 12. We can actually tell the calculator to calculate a whole bunch at the same time for us. And to do that, we use Binomial CDF. CDF is cumulative. CDF is cumulative. Cumulative means you never remember the cumulative frequency. It just keeps adding. That's what this does. Cumulative function. Same definition. N is where your number of outcomes is. P is your success. X is the maximum number of success to calculate. So what is your max X? So it's going to always start from 0 all the way until you tell it to stop at some X. This takes some practice. We're going to learn how to use and manipulate this. If you have that older calculator, same format. Binomial CDF NPX. Rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. So I'm going to spend a little bit of time on this so we can understand how this actually works. Alright, so nothing is being taken back, nothing saying it's not replaced or anything like that. So this is a binomial experiment. So let's identify our N, P, and X. N, is not 0.9. What's N? N is our number of patients, 3. IP, 0.90. Now X. Our possible X's are 0, 1, 2, and 3. But it says exactly 2. Exactly 2 means we're only going to do this as our X. We only want X equals 2. We're not doing 0, 1, or 3. So exactly, the word exactly means only 1. So if you want to put a little note up there of the first option of Final PDF, that's only for exactly. So let's work this out manually first, and then we're going to work it out in the calculator. So manually, I'm going to find P2, excuse me, P2. Let me get my P2. Is equal to, and I'm just looking up here at my formula. 3 is my N. I'm choosing C. Then my passing rate is 0.90, and I have 2 that are successful, 1 that isn't successful. Let me come to the side and kind of work this out so you can see what this actually means. So exactly 2 successes out of all the ways you can have 3 patients successful. So this is actually saying out of 3 patients, we have success, success, failure. We have success, failure, success. And we have failure, success, success. That's exactly 2 successful. So out of 3 patients, I can have a first 2 successful, failure, success, failure, success. So 2 S's, and then failure, success, success. I can't have this any other way with exactly 2 successes. So that's what that is, and that means that this is actually 3, but we're going to work it out all together. We're putting it all together, or you can work it out manually. Meaning you do the 3 factorial, 3 minus 2 factorial. Over 2 factorial. If you want to do that deep, you can. I'm going to put all this in the calculator. I'm going to put this in the calculator. Alright, you ready? So manual does take a little time. Not bad, it's a little time. So here we go. I'm going to hit that math button, 3 first, then my math button. 3, math, and find real quick in that first row. Over to PRB or PROB, 2. One to the right. So hit that right arrow to make sure it's B. 0.90 to the second power times 0.10 to the first power. Ooh. There's my caret button, just in case you can't see it. Caret to the first power. That takes a little time to practice. If you do these manually, you're going to have to practice this and be proficient at it. So this is 0.243. Alright, so calculator. Because we're only finding one, we're only finding x equals 2, we're going to use binomial PDF. Binomial PDF. It's going to be NPX. NPX. I'm going to put it in the calculator. I do this for those who have that older calculator. So I can set it up this way, but then I'm going to put it in the calculator the way I need to put the calculator. So binomial PDF. We're doing PDF again because we're only asked for exactly 2. So when it says the word exactly, we use binomial PDF. Alright? So I'm going to second bars right here. I kind of cheat and go up to A. Instead of going all the way down to the 1 through 0, I go down to A. That's my binomial PDF. For those who have that older calculator, stick with this. Our trials, remember, trials just means our sample size. Our passing rate needs to be a percent or a decimal. And then our X is the one we're trying to find specifically. I make sure it matches. And there we go. So it's up to you if you want to work these problems out manually because it makes sense to you, or if you want to put it in the calculator. And there's one more way that we're going to learn how to calculate these, and again, you're going to use the way that just makes sense for you. So the last way to calculate this is going to be putting it in the calculator and letting all the probabilities calculate at the same time. So you remember how we did the relative frequency and we let the calculator calculate all our probabilities? So binomial problems, distributions, they can be done the same way. And we're going to do our problems down here that way. Okay, so let me go through this real quick. So we're going to list all the possible values of x. All the possible values of x, and then we're going to calculate the probabilities. So all possible values of x go in L1. Don't forget 0. A lot of people forget 0. If you use this method, you've got to put 0 in all the way to n. Now you're going to, L2 is going to be our probabilities. We're not going to enter them, we're going to tell the calculator to enter them. So we're going up to L2. We're going to put in a binomial PDF, n as a number, p as a number, and then L1. I know, it's going to be weird. Yeah. So binomial PDF, n as a number, p as a number, and L1. We press enter, and then we're going to see all of our probabilities. So we're going to do this example down here. So buckle up, because it's going to be a little ride. Just make sure my papers are right. I feel like I was going out of order. Alright, a survey found that 22% of U.S. adults say the economy, and employment and jobs are most important problems facing the U.S. You randomly select 4 adults and ask them whether the economy, unemployment and jobs are the most important facing the U.S. By the probability that exactly 2 of them respond yes, at least 2 of them respond yes, and fewer than 2 of them respond yes. Alright, so let's look at our numbers first. What is our n in this problem? What is our n? What's our sample size? 4. And then what is our p? 0.22. What is our q? 0.05. 0.78. So remember, that's 1 minus P. And then for our x's, what are all of our possible x's? So that way we can look back and see. Oh, I already have them here. Those are nice this year. Normally I don't do that. But Merry Christmas. So those are all of our possible x's. Alright, so let's practice this part up top so that you will see the third way of doing these problems, and then we'll work with all these problems. I'll work with all the ways. So we're going to put all of our x values in our L1. So let's stat, edit. I'm going to just write over these so I have enough. 0, 1, 2, 3, and 4. Alright, so let's calculate all our probabilities at once. So this will actually give us all of our probabilities at once. I'm going up to my L2 where it's dark, and I'm going to hit enter. I have something in here, so I'm going to clear this. Normally it's blank, but once you hit enter, it should be blank. Mine wasn't blank, so I'm going to clear it. So we're going to go get Binomial PDF and put it in here and tell the calculator to find each of these individually. So Binomial PDF. So second bars. Binomial PDF. N is 4. P is 0.22. And our x value, because we're inside of a list, I'm going to put L1. Second number 1. Second number 1. Hang tight. If you have that older calculator, it's going to pop up in a minute. So everybody should look like this. Binomial PDF, N, P, X. X is going to be all of these. And what this does is it calculates all of your probabilities at once. So you don't have to do binomial PDF, you don't have to do binomial CF. You just use the numbers that you need. Now I normally write these down, if you're going to use it this way, as a chart. So this chart is only if you use this. This chart is only if you use this. So let me write down these numbers really quickly. I'm not going to write this number down. I'm going to write this number down. Okay. You'll see in a minute why. So I'm trying to write, as you can see at the same time. So 0.3701505. And I'm not rounding. See, these numbers are rounded, and that's why I don't want to use these numbers. 0.471. That's up already. I don't know if you know this, but I'm not really good at doing two things at one time. I lost my whiteout. Alright, 417. I'm just going to put some numbers going down. I'm hitting the down arrow so I can read these numbers. I'm hitting down arrows so I can read these numbers. Because this is a number that's not rounded. See how this is 0.1767? It's because the calculator automatically rounds the numbers. I don't want rounded numbers. I want my original numbers. If I'm going to use this, I don't want rounded numbers. Next is 0.033221. Let's see that again. Well, not that one's rounded. I think this one's rounded. 0.002342. So I'm just writing down numbers that I can use. So this is a third method if you want to use how you want to calculate your probabilities, and we're going to see how this actually works. So first method was manual, second was using binomial CDF and binomial PDF. Third is this distribution where we actually make a list of our probabilities. So let's continue to pause. I know that was a lot. If you need to pause, say woosah. Okay, we're back. So let's get to the problem. So we want to find a probability that exactly 2 of the 4 people responded yes, based on our calculations. So I'm going to do one down here. So first, let's do the manual way. Exactly 2 means x equals 2. So we are looking for P2. That's it. P2. So with P2, manually, this is what it looks like. 4C2, 0.22, 0.78, 2. So this is 2 for x. N minus 2 will give us our failures. So how many do we have failing? Out of the 4 patients, 2 exactly 2 were successes, and then the others were failures. So if you want to do the problem that way, pause, get your answer. Those who want to use binomial PDF, we're using PDF because this is exactly for this one. So binomial PDF, what are we putting in? Okay, we have N for our trials, P for our success. Close it. I'm not closing. And then the last is our x of 2. Pause, get your answer. If you're working, I might grab a space. This is the manual way, this is the calculated way. If you're using your chart that we just built, then we're going to just go to x equals 2 and write down that answer. So our answer should be P2. This is the only one. We add all the ones that we want, but we're not adding anything because we only have 1 to look for. So I normally do 3 decimal places. We do 4. So our answer is going to be 0.177 or 1767. Sometimes they want you to do 3, sometimes they want you to do 4. So it depends on what they want you to do. Ooh, can't see the camera. So let's do the calculator. We've done one of these with the calculator. Let's do the calculator for this one. Binomial PDF. So second bars. Binomial PDF. So my computer went to sleep. 4.22, and we're going to put a 2 in. There's that number. creative. Let's go ahead and do this one since we're on the calculator. So I'm gonna put in a 4. Do this really quickly since most of y'all probably did this already. Let me delete this. Delete. Alright, on to problem number 2. Make sure to read the screen. Okay. So 2 is at least 2 of them respond yes. At least 2 respond yes. That's what it looks like in equality or algebraically. So what does that X mean for us? At least 2. So 2, 3, and 4. So if you're going to use the manual way, I'm going to write it out. I'm not going to put this in the calculator. I'm going to write it out so you can see exactly what you're going to need to do part by part. Alright, ready? My manual view. Here we go. So X equals 2. Four C2. 0.22 squared, 0.78 squared, plus X equals 2, X equals 3, 0.22, 3, 0.78, 1, plus, you got this, 4, C. Now if you don't want to do the manual way, just hang in there, I'll get to your way in a minute. 4, 0.224, 0.780. That's what you're working with. So I have my X equals 2, X equals 3, X equals 4. Pause if you need to. Okay. If you're going to do binomial PDF, you're going to do the same thing. So binomial PDF. So remember, PDF is only exactly 1. So you're going to have to do the 2, the 3, and then the 4. The 2, the 3, and then the 4. So binomial PDF, people, if you're going to do binomial PDF, we have 4, 0.222. Get that number plus binomial PDF 4, 0.223. Get that number. Binomial PDF 4, 0.22, and then 4. So let me show you about this binomial PDF. How you can, actually all of them, how you can copy and just change the numbers. So second enter will allow you to copy the lesson you put in, and you can actually write over the numbers you need to write over. So second enter will allow you to do that. I'm going to go up to this one. For Binomial PDF, same thing. 3. Second enter. 4. Oh, I forgot that one's supposed to be. It's supposed to be 3 and 1. Sorry. I was like, why not the same? Get 3 and 1. Sorry. There we go. That makes sense. Yeah. So second enter will allow you to copy and paste. So that way you don't have to do it over and over and over and over again. Alright? So this is the manual way. This is the Binomial PDF way. If you want to use Binomial CDF. Because CDF I can use now because remember, I'm finding more than one at a time. But here's the kicker. Binomial CDF only works when I start at 0. So, when it doesn't start at 0, hold on to your horses. When it doesn't start at 0, you're going to do 1 minus Binomial PDF, Binomial CDF, excuse me, up until the X that you want to stop. I want to stop at 1 so I can pick up my answers at 2. So if you do 1 minus here, I normally have the trick of do 1 minus here for your X. I do 1 minus here because it's not starting at 0, so I have to start at the X, stop at this X so my answers can pick up. Let me do the 1 minus Binomial CDF thing, and then we'll do the chart next. 1 minus Binomial CDF, again, because it's going to calculate all these X's for me until I stop. 4 trials. My P is 0.22. I want it to stop at 1 so that it can add 2, 3, 4. So I'm telling Binomial CDF to stop at 1. I do 1 minus so that 2, 3, 4 can be calculated. So all of our answers should be 0.212 or 0.2122. Now let's calculate this with the chart. Remember the chart? Remember your chart, so you don't even have to really write them down. I guess you don't. You can just add straight from your calculator what you want, but I don't trust these because they round. But you know, you can do that if you want. So 0.17667 plus 0.0332 plus 0.0023. So the reason why I do this is because look at this. If I do 3 decimals, it's not going to give me a really good answer. It's going to give me a okay answer, but not the best answer. So I want to add these together. All have 2, 1, 2, 4, 2, 1, 2, 2 as our final answer. Alright, this last one. Pause and see if you can get these together, and I'm going to, or you can pause, or I'm going to quietly write this out, the next one, so that you can see if you're getting this, if you're understanding this. And if I don't see you, I might have to help you. But pause to see. Well, pause, or I want to work quietly. You can just keep it on. Hopefully, it's not too much background noise. And you can look at the method that you want. So just put the method that you want to use down for this last one. I want to do all of them. So, yeah, sorry, just be quiet. All right, let's see what you got. So we didn't have to do all three methods, all four methods, well, three, kind of sort of. You have to do all of them, but whichever one that you felt most comfortable with. So fewer than 2 means x equals 0 and 1. Because 2's not included. So this is the manual way of doing your problem. This is Binomial PDF, so you have the 0 and the 1 you have to find. And if you want to, you do Binomial PDF, you can actually just add all them and just keep adding them instead of finding the numbers individually. You can put these in all at one time. So you do Binomial PDF, the 0 plus Binomial PDF, the 1. You can do that. Binomial CDF, because we're starting at 0, we don't need a 1 minus. Because we're starting at 0, we don't need a 1 minus. So it's just 0 and 1. And then for those who use a chart, just add those two numbers together, round to the nearest hundred, and we all should have gotten 0.788. Let me check this last one. Let me check the last one. I don't have this one as an answer. Sorry, let me just check. Oh yeah, here we go. So whatever way you want to do this, it takes me a long time because I have so many ways to do this. I'll probably do a separate video with one extra problem just to make sure you're good with that. All right, hang in there. We got a little bit more to go. So graphing a binomial distribution. So we use a histogram to graph because it says distribution. Sorry, my notes failed. We can have life together. Okay, so you're going to calculate each of those p of x's however you want to choose. So if you want to put the probabilities in with Binomial PDF individually, and find those numbers, or let the calculator calculate them all together. Like we did with the binomial PDF and PL1 thing. Do that. And then we're going to graph. So turn the stack plot on y equals. We're going to make sure the histogram graph is chosen. Histogram graph is the one that looks like this. Alright, my art. And then we're going to zoom stack. Alright, so let's practice with this one down here. 62% of cancer survivors are ages 65 years or older. You randomly select 6 cancer survivors and ask them whether they are 65 years age or older. Construct a probability distribution for the random variable x, then graph the distribution. Alright, so here we are with our random variable x and then our p of x. So we're not actually calculating with these. So we're going to round these in the in the middle. Okay. So what are our possible x's? What are our possible ways of success? N is equal to 6. So our possible ways of success are 0, 1, 2, 3, 4, 5, 6. So again, however you want to calculate these, you can calculate these. You could do binomial PDF, binomial PDF, binomial PDF, or we could do them all at once. I'm going to do one binomial PDF, and then we're going to do it all at once. So you can see, you don't have to do that list thing if you don't want to. So I'm going to do my binomial PDF, second bars, binomial PDF, for just a 0. So our n was 6. P is 0.62. Notice it didn't put it in. They'll normally trick you up like this, so just be careful. I'm going to put it in word form. 0.62. And then our x value is going to be 0. So 0.003. So we're going to round these. Again, we're round them because we're not doing any other work with this. Go second, enter, 1, and just keep going down if you like. I'm going to go to the list and do this for those of you who like to do the list. So that second one's 0.02. 0.0294 and so forth. I'm going to go to the list. Stat, edit. This is for my people who like to do the list. Don't worry, if you need to pause this at any time, y'all please don't think you have to keep up with me. Pause. Okay? If you need to. I don't have to clear this because it will clear by itself. I'm going to clear it. Just, out of habit. Sorry. I cleared it. I always clear them. So clear. So notice it's dark. It's clear. So I'm going to put my binomial PDF in here because it has to do them individually. I can't use binomial CDF because I don't want them to accumulate. I want the calculator to do them individually. So second bars. If you don't like this way of doing it, please don't think you have to do this. Okay? So 6 is my n, 0.62 was my p, my x value, because I'm inside of a list, is L1. Let's see, it calculated all of them for me. 0.029. And see, it made the 5. But according to this down here, it's actually 0.029. So down here, that's the one you want to stick with. 0.029. And number 2, 120. Number 3, 262. Well, it depends on, however they tell you to round it, because you normally don't get a choice of how to round. They're going to tell you how to round it. But don't rely on this, rely on the bottom number. We're almost done, y'all. Hang in there. Hang in there. Now to graph this by hand, I'll do a quick graph in the end, but let's graph this in the calculator. Okay, ready? So we have L1 and L2 in here already. If you don't, you could graph it by hand on paper, but you're going to have to know how to graph it, using our system. So you might want to just write those numbers in your L2. Second mode to get out, you'll always reset with second mode. Second y equals, because we want to graph. Stat plot. Remember, this is the algebraic calculator, but we normally use the stats. My stuff is on. I have my histogram, my L1, L2, everything is on, but if you don't have it on, hit enter. Turn it on. Make sure it's dark and blinking. Make sure you hit the histogram. Make sure your X list is L1. Frequency L2. If it's not L2, second number 2. If X list is not L1, second number 1. So we hit the second button again because it's in blue, and that's what we want. Second number 2. We're not going to hit graph because we don't want a traditional graph. We want to zoom into our statistics. So zoom number 9. Oh, it didn't work. Okay, it didn't work, so we're going to have to graph it our own selves. I've got to figure out why this doesn't graph. What I want it to. Alright, so let's graph. Faithful 5s will work. Just gotta know where to stop. My highest is 32s. Let's stop at 35. I wish I could say this graph was drawn to scale, but it's not. Okay, so now we're going to draw all of these. So 0 is 0.003, so we're pretty much just going to draw a line like this for 0. Because it's really, really small. So 0.003 is less than a penny. This is about 3 cents, so we have a little bit of bar right here. For 1. That's 12 cents. I make everything money because it just makes sense to me when I'm making money. So dollar bills are whole numbers. Decimals are just change. 0.26. 0.32. Sorry, it's a little. 0.32. 21, sorry, my phone is just this graph look like to you? What does this graph look like? Look at that little tail going this way. So this is more skewed left. Skewed left. So let's talk about this graph because we're going to talk about mean, variance, and standard deviation in a minute. So remember, when we talk about mean is where we think the middle of our graph is, and that's where most of our data is. So our bars are peaking here, so that's not in the middle, but it's peaking somewhere in here. So that's where our mean is going to be. Let's talk about how to calculate mean when we have those probabilities. So with discrete probability, we use the relative frequency. And with the other, we did, I forgot what, oh, we just used the chart for our for mean, variance, and deviation. So now we have formulas. This is on your formula sheet. So mean, you have N and P. So always look at what the question is asking me and what I actually have to see what formula I use. So when it's asking me to find mean, if I don't have a probability, then I'll probably have an NP or a passing rate, and this is my NP. This is my NP thing. So N times P is mean, variance is N times P times Q, and then the square root of standard variance, is N times P times Q. Standard deviation is the square root of N times P times Q. It's getting towards the end of the day. My brain is woo. Alright, so find the mean, variance, standard deviation of the previous example. So let me just write down our numbers from the previous examples. N was 6, P was 0.62, Q was 0.38. I know we don't use Q a lot, not unless you're going to work these problems out manually. That's when you use Q. So even that last part, if you didn't want to use the binomial PDF or CDF thing, you could have used your combination. This would have been 6C0.62 to the 0.38 to the 6. For those of you who want to work it out manually. So let's find the mean. Mean is equal to N times P. So it's 6 times 0.62. And that matches our graph. That matches our graph. So we bring that graph back. Yeah, so that was our peak. So right before our peak, probably our middle. So that matches our graph. That makes sense. So make sure your answers make sense. Mean, remember, is a measure of central tendency. So your mean should be somewhere in the middle. So if our mean ended up being 6, that doesn't represent where most of our data is. So even according to our percentages, most of our data is right here in the middle. So our mean should be somewhere in there as well. So that's what we're doing. We're trying to calculate our mean based on our probabilities and based on our passing rates as opposed to our actual data. Because we can't look at the 0 through 6. We have to look at where is most of our data in that 0 through 6. Alright, N times P times Q. So we're going to have N times P. So you can do that times Q, but just for these purposes, N times P times Q. So for no purposes, I wrote it out, but I already have n times p. Just gonna multiply times q to get our variance. 1.41. And then standard deviation. I don't want to take the square root of my answer. I want to take the square root of those numbers. When I take the square root of the answer, I'm actually skewing my numbers. So you can do second answer, square root second answer. But I'm just gonna write it in 6 times 0.62 times 0.38. 1.19. Notice I have a note here. It says that one bar stat may also be used if you use the table. So let me use my one bar stat to see if I can get these answers as well. Pull this up right here. You don't have to do this, just going in and show you one bar stat, L1 and L2. So don't forget, if you have a frequency list, put it in there. Just showing you, you don't have to write this down. There's my mean, and there is my standard deviation. Again, it shows you that it knows you're working with binomial distribution, so it only uses population, because it's using probability. And then you can just square that number out, 1.8894. To get that standard deviation, to get that variance. You may have to watch this twice, or skip over some parts. This is very, very heavy. So again, find your method and stick with it. Find your method and stick with it. I'll do one more of these problems out of the book, or just one listed here, just to make sure you're good on a separate video.